Good evening. Hey, Alex.
Hey, good morning, good evening, or good night, depending on wherever on the world you are. How you doing, Haney?
Yeah, I'm doing pretty good this evening. How are you, Alex?
I'm very fine, thank you. Evening it is indeed. It's actually almost dark outside.
Yeah, same here.
It's so fantastic to see you again, Heini. It's been a while.
Yeah, it's been a while, but glad to be back and glad to see you here as well.
Yeah, me too. Me too. So, welcome to everyone in our audience, and welcome to yet another episode in this fantastic series of the Cosmos DB series of Microsoft Learn Live TV. Today, we're going to talk to you about implementing a non-relational data model. What about that, Heini? I think it was time to actually talk about non-relational data and why do we call this NoSQL thing NoSQL.
Yeah, exactly. And I find this topic to be so interesting. I think kind of once you get this, it kind of all clicks into place and you start to see where this can be very useful and powerful.
I couldn't agree more. I think this is probably one of the most important lessons out of the entire series. Of course, it's very important to talk about the SDK. It's very important to talk about gateway versus dedicated connection modes. It's important to talk about indexes. There's so many fantastic topics. Don't get me wrong, but properly understanding data modeling, properly understanding how to think about throughput, hot partitions, logical partitions versus physical partitions. Like there's so many topics to talk about, and I'm so
There
excited
is.
for today's session.
Yeah.
Well, let's not waste any more time. Let's actually introduce to our audience also our fantastic moderator, who does not get a chance to shine on the live stream, but we do give big kudos and thank you for Chris. Chris is a fellow Microsoft Most Valuable Professional on the Data Platform Award category, and he is actually your moderator today. So why do we mention this? Because this is live TV. If you have any questions, whether you're streaming in on Twitch, YouTube, Learn Live, LinkedIn, Twitter, or wherever else, make sure to stay interactive. So I've introduced Chris, but what about us introducing ourselves maybe?
Yes, I think that might be a good idea. I am Heini Ilmarinen. I am a data platform MVP and I am located here in Finland. And I work as a DevOps consultant for a company here in Finland called Polar Squad, and we focus solely on DevOps. And Cosmos-db is one of my favorite topics to talk about. It is a very interesting service that we can use for a lot of solutions.
But let's be fair, it's very easy for Cosmos to be one of the favorite topics because it's such a enjoyable topic to talk about in the first place, right?
It is, exactly.
Thanks for the Heini. And my name is Alex Mang. I'm going to be your co-host for the day. I'm a Microsoft Most Valuable Professional on the Azure Award category. Azure is my turf. I've been using Azure for the past 12 years now, literally ever since Azure was a baby and I got keen of it. And Cosmos DB happens to be one of these fantastic services born in Azure, born in the cloud with the mindset of the cloud built right in. And if you have been watching this series throughout with the other episodes, you probably have already learned all the capabilities that Cosmos DB has to offer. Now, I would not want us to skip this introductory part where we're presenting other people who are actually part of this entire effort, because there are a lot of principal program managers and producers. We do say hi to Jason and Laurent and Tina and all the fantastic people who put together such a fantastic work and such a big effort to make this series a reality. And thank you for that. So this is part of a series. And what people have to understand is that the series we're following is actually a Microsoft learning path. Right? So for every episode, there's a module. So today's module is, well, surprise, surprise, has the same title as our episode today, namely implement a non-relational data model. Now, if you want to take full advantage of your learning experience, both on Microsoft Learn and here with this live TV episode, I would encourage you not to open up the Microsoft Learn module right now, but rather wait until the end of this video or make yourself comfortable over the weekend and work on the module at your own pace, get your hands dirty. The reason for I'm saying that is that we are definitely going to show you some tips and tricks today, as we have done so in the other episodes. Make sure to watch the other episodes if you haven't watched them yet, because these tips and tricks will make you more productive, more professional, and much better equipped, I would say, in your overall Cosmos DB learning experience. Haney, why do we even teach people on Cosmos DB, except for the fact that it's such a great product?
It is such a great product, and you can use it for so many different purposes. But specifically, this learning series has been built to prepare you for the Cosmos-DB certification that has come out. So that is kind of specifically what this series is aimed at, and it is the Azure Cosmos DB Developer Specialty. And it is one of those Microsoft certifications that is very directly kind of just focused on one area and one product. And in that way, it is really nice because you really know what to focus on. And there's not like all of Azure that you need to be able to cover, but you can just actually dig very deep into this one specific service.
I do appreciate these kinds of exams and certifications, which are quite niche to a single product. Of course, you might argue that you only know one product rather than entire skill set or an entire industry or whatnot. And I do get both points. But sometimes when, especially with technology such as Cosmos DB, there is a bit of a learning curve to it, and there is a bit of a mindset shift that has to happen for you to properly understand how to take full advantage of the technology, and therefore focusing on the very deep level, like going very deep into your knowledge and with your learning experience when it comes to Cosmos DB, is definitely going to pay off when it comes to actually implementing Cosmos DB in your own applications and architectures. So
And
today's sorry
able
about
to
that.
have a full certification on one topic just shows how complex it is. There is many things to learn about this particular service.
100%. I couldn't have said it any better. Now, we have already mentioned a couple of times what our today's title is, implementing non-relational data models. But let's maybe focus for a second on the actual learning objectives. Haney, do you want to cover those maybe?
Yeah. So first, we're going to be discussing about different kinds of access patterns that we can have for our data. And then, of course, after that, we're going to bridge that into then how we then create our model based on that. So that brings us to really applying the data model and then having these different partition strategies that help us have efficient queries to our NoSQL database and also make it scalable for our use case.
Again, I couldn't have said that any better. But in all fairness, this is a live interactive session, and I want to emphasize the interactive part. So make sure to remember that this is live. Make sure to remember this is interactive. And just head over to the chat window, even right now. Just say hi and ask any questions that you might have, even as we go through the material today. We'll answer your questions. Chris will do a fantastic job answering them. We'll pick some of the questions from the audience. But even if we don't get yours on the live stream, our moderator, Chris, is going to answer your question. And actually, Heini, I think you had an idea before we went live, didn't you?
Oh, yes. We were talking about relational and NoSQL databases and how we're kind of today going to get to the bottom of like, what is the difference? And we were also talking about, well, it would be nice to get some stories from the audience of using relational databases. And of course, even better if you can have some experience in tying that with comparing with NoSQL databases. But any stories you have from using relational databases or even then taking that to the NoSQL world, we're very interested in those, and we'll get that information relayed to us from the chat. So just let us know what you have in mind, and we'll try to pick them up in the end of the session today and tie them in.
Absolutely. Remember, this is a community, and we all are here for the same purpose. We want to learn. So we want to learn from your experiences. Everyone else in the audience wants to learn from your experience, and you're here to learn from us. And we're going to share as much as we can, obviously, to our best extent. So if you have any horror stories, if you have any non-horror, but rather romantic stories that you want to share with Cosmos DB, or relational versus non-relational, or whatever else have you, I'm sure there is something that everyone here can learn from and learn about. Cool. Thank you for that. I think that's a fantastic idea. And I'm really looking forward for the audience interactive and letting us know what their stories are.
Exactly.
Cool. I'm pretty sure that we have some newcomers, even though I believe this is the 14th episode. I might be wrong. Maybe it's not that far away in our series, but I do believe that we definitely have some newcomers in our stream today. So real quick, Cosmos DB, how would you define it, Heini?
Well, Cosmos DB is the Microsoft offering for a NoSQL database. So, and on the other hand, it is also fully managed. And what that actually means is that you don't have to manage any kind of server or install any software on that server or anything like that. It is a fully managed service. You just put it up and then you start gathering your data in there and get right to the data layer when you are using it.
Indeed, indeed, indeed. So Cosmos DB is also quite interesting because it allows for increased scalability, horizontal scalability, and it supports data sizes that go well beyond the typical relational database that your father's or your uncle's or your grandfather's SQL server might have looked like, right? Horizontal scalability at the same time also means that the database has the capacity of providing predictable performance. And there are already some keywords here which are kind of rooted in the cloud. Scalability, elasticity, which I kind of mentioned to an extent, predictable performance, which is sometimes very hard to achieve. But the idea is that if you want to achieve this level of scalability, for instance, right, the users, they need to understand both the concepts and the techniques which are unique to NoSQL databases for data modeling and for partitioning the entire data set. Understanding these concepts properly will ensure that you can scale an application. Sorry, you can scale your data set to the right extent. It's just like with an application. Back in the day, I still vividly remember 2 decades ago, the free tier applications that we developed back then, and we thought that we were all modern because we have an API and we have whatever database, and we have a front end, which is a single page app or whatever other framework, not 2 decades ago, in all fairness, but you get the idea, right? That is anything but scalable. Now we know better. Now we develop microservices. I wonder what the next big deal will be. But but quite a close analogy to this one is how Cosmos DB and thinking about your data in partitions and thinking about your data as entities that you want to do a point read operation on and whatnot is actually very different from the binary trees that you would maintain indexes on in your relational databases and achieving your data access over there. Cool. So throughout the episode today, we're gonna work on this given scenario. Just imagine that you work on a retail startup which is designing a database to manage online orders, the typical canonical e-commerce application, right? And you're working on a proposal for an efficient database design, which is obviously going to use Cosmos DB because that's our topic today. So you've been provided an entity relationship model to start with. This is what the old CTO who just resigned, or well, not resigned, but maybe they went on a pension. This is what they initially had, right? They had a customer table, a customer address table. These customers had to log in somehow. So there was a customer password table. There was some product categories and products and a bunch of one-to-many relationships among them and a many-to-many relationship with the product tags. And there's a product tag with its unique identifier and whatnot. So there's a lot of complicated entity relationship diagrams here. But the purpose of this diagram here is just to kind of give you a better understanding of the details of the 9 different entities that we'll be working with. Customer, customer address, customer password, product category, product tag, product tags, sales order, and sales order detail. And by all means, Heini, I think that you have definitely seen this several times now, maybe in a different layout, maybe with different colors, but this is quite canonical to the e-commerce sample, isn't it?
Yeah, it's very similar to other examples from a similar scenario. And kind of if we look at this relational table model, we already see certain things about this. We see, for example, the IDs in each table and how the relationships are done then with the primary keys and then referencing that ID in another table as a foreign key. And as we move through this module today, we will be kind of seeing how do we translate this relational model into a model that we use then in our NoSQL database instead. And how does it translate? How do we actually create a table that is efficient on the NoSQL side?
Absolutely. And that's going to be one of the most important aspects when it comes to properly implementing a NoSQL model, which we by design want to make scalable, like highly scalable. So what are we actually going to do? Well, we're going to take this existing relational model. We will have it redesigned as a NoSQL database for this e-commerce fictional e-commerce application that we're thinking of, but the sample is quite canonical. And during the process, we are going to teach you the differences between relational versus non-relational databases, and we're going to explore some of the differences between NoSQL databases and relational databases and why they are that way. We're going to start using an application data access pattern to model the data, so you understand more on how application reads and writes can influence the model that you would implement in NoSQL databases, because no fairness in SQL Server, for instance, the way you do a read versus a write is virtually irrelevant. Up to an extent, depending on the amount of data that you'd pull. But that's a different conversation that I do not want to open. I don't want to open that box right now. We're going to leave that for the next episode. And we're also going to learn when you should embed data, which is something that normally you wouldn't do in your relational databases, versus use a reference, because there still are some reasons and some scenarios in which using a reference is going to be important. And then we're also going to talk and teach you some of the key concepts which are needed for choosing the best partition key for the purpose of avoiding hot partitions and optimizing workloads that either read or write, are read or write heavy, or maybe both. Sometimes there are going to be doing a lot of I/O, both for the purpose of reading data or writing data. And then last but not least, we'll learn how to model data that's used as a lookup or a reference for other data. So we do have quite a lot of things to cover today, but we do have some few tricks up our sleeves as well. So when we'll finish this episode today, you have all the right knowledge and the skills to properly model and partition data. So honestly, Heini, I'm just super excited and just looking forward to going through this module and through this material with you.
Yeah. And I think this is so interesting that this is actually a requirement for the exam, and that is why we're going through this. And if you think back on the Microsoft exams and maybe have done even some data platform related exams before, and you might think like, well, there hasn't been a lot of questions about data modeling. But in this particular one, there actually is. And this is a really core area to get familiar with and understand these different concepts that we're going to be going through. And I think that's pretty cool that there are these modeling questions in an exam.
Absolutely. And it's actually one of the biggest part of the exams, if I remember correctly. I take this with a grain of salt, but I believe that 25% up to 30% is actually covered by understanding data partitioning, understanding data models and implementing data models and so on and so forth. So I can only speculate that there will be definitely a good number of questions on this very topic. And this is also why this particular episode is so important. Good. So what's the difference between NoSQL and relational databases?
Yeah, I think that must be the main question here.
I think it is the main question. You know, at one point I was talking to a good friend of mine who happens also to be a data analyst, data scientist, and he argued that NoSQL actually shouldn't be understood as not SQL, but rather not only SQL. And I find it to be very interesting for the purpose of polyglot persistence, where you pick the correct technology. Correct may not be the right adjective here, but you pick the one technology which is specific to the implementation that you're looking for. So to give you an example, if you want to have a recommendation engine, sure, you could potentially write a recommendation engine in SQL Server in a relational database, and I could be looking at my history and run a lookup on that with my sales and my orders over the past years. And then I could look at all of the other users in the system and all of their orders and see how many of those overlap over the whatever period of time. And yeah, these two might match, but it is an overly complex process, not only in terms of authoring those queries, but also in terms of the CPU and the I/O that you would actually consume to understand or answer this question, right? Now, if you take a couple of steps back and think of the same implementation where your data is represented as vertices and nodes and so on and so forth, and implement, say, the Gremlin API, answering the same questions where some things are shared, are common to some of these nodes, is literally one operation. because of the way the data is structured. So when we say NoSQL, we do refer to a different data structure, because that's at the end of the day the main difference. But at the same time, this NoSQL technology is not here to replace SQL. It is here to maybe compensate on the shortcomings of SQL. Running a report is still going to be fantastically well put in the SQL world. Want to get your monthly savings or your monthly sales or whatever else, or maybe your semestral sales, they most likely will make more sense to be read from, persisted, written, and so on and so forth in the relational world. But want to work with the model that is dynamically expanding and changing in size because your developers are cranking up new features every other sprint? Well, if your model is changing so often, not having to obey a strict model, as would be the world of the SQL, but rather being able to shift that model a lot, as is the case with NoSQL, might make more sense, right? So
Yeah,
not only SQL is the way you should think about NoSQL.
exactly. And maybe in the way that these two actually complement each other and they
Absolutely.
just give us the possibility to cover more use cases in a reasonable way.
Complementing is uh, a very well put adjective here.
Yeah.
So in general, the NoSQL databases, just like Azure SQL, Azure Cosmos DB, in fact, is going to be characterized as being horizontally scalable and non-relational. So what does this even mean? It means a number of things. Relational databases, they typically grow by the increase of the size of the virtual machine or the compute that the database is hosted on. So NoSQL databases would scale up by adding more servers or nodes. And these nodes are also known as physical partitions in Cosmos DB. And the data stored on these physical partitions needs to be organized so that it can be efficiently accessed later on, right?
Mhm.
What about the data? The data is usually predictably routed to different physical partitions by using one given value inside the entity that you're working with. And this value obviously has to be a required property, and it has to exist on every single entry point in your data set. We usually call these a document in a document NoSQL database, for instance. In Cosmos DB, you also call them documents because Cosmos DB with a SQL API happens to be a document node database structure. But we're going to talk about that later on. Now, this one property I told you about is going to be called a container's partition key. And this partition key needs to be specified when you're creating the container, like which property out of the documents do you want to use as a partition key. That's what effectively you're saying, right? And it is very important to specify it because when you're passing the partition key, when you're writing the data, I mean, or reading from the container, you can ensure that the operation of either reading or writing is going to be efficientized. And this will make a ton more sense, I promise you that, once we look at how the data is actually written in these partitions. But for now, let's just think of the scenario, because although the need for a partition key might look like a constraint, it actually comes with a fantastic set of benefits, enormous benefits. Typically, thinking about relational databases, they can possibly grow. In all fairness, they will grow, but there is always this threshold, this sweet spot where they cannot grow any more than that. They can grow in terms of gigabytes, no problem, in terms of terabytes even. But at some point, they become very heavy even to maintain, to operationally support, and so on and so forth. The NoSQL database can grow, well, in theory, at least to unlimited sizes. But especially when they're hosted in a cloud system, the size itself is virtually irrelevant because there's no centralized one single index that would overarch and oversee all the data set. Then the index itself would at some point grow and it would be virtually impossible or irrelevant to use it anymore because the execution of the estimated plan just times out every time, as it would be the case with your relational databases. So in non-relational, things get a bit tricky, but at the same time beneficial by using these partitions. Okay, I think I've talked a lot about these partitions, and I'm super excited on the way things are structured in Cosmos DB, but it is a bit theoretical. So Heini, make sure to like put the brakes on when you see me rumble
Yeah.
too much on these.
Yeah, I think what will help with this topic is this difference, understanding this difference between non-relational and relational databases. So I was kind of pointing to this already when we were looking at that picture of the sample that we're using in this case. So for example, in a relational database, we always have those primary keys and foreign keys. We also often have constraints on data types and things like that. And we have relationships between these different tables that we have in our database. Whereas in a NoSQL database, we actually don't have these. So that is why we also need to have kind of a different way to even structure the data in the NoSQL database than the relational database, because we don't have these keys and constraints and relationships in place. So of course we need to kind of approach it in a completely different direction.
Yeah, absolutely. So one might answer or might ask, and it will get an interesting answer. Why are these database types so different? What would you answer, Heini?
Well, of course, the history here is very different. We've had relational databases around for a very long time. I believe they
50-ish
have
years. Yeah.
Yeah, exactly. Tens of years from the 1970s, as so forth. They've been growing and growing. And in the beginning, the cost of storage and memory were kind of relatively to the cost of compute, they were kind of high. And
Yeah.
so we wanted to always normalize our database model and reduce duplicate data as much as possible. So then,
Sorry for interrupting you there.
go ahead.
I remember when I was, well, I wouldn't necessarily say a kid. When I was in my early days of computing, I would sometimes hear these words like normalize, denormalize. Maybe somebody is completely new to this world. What does normalization or denormalization even mean?
That is actually a really good question to ask. So in normalization, we are kind of putting the data in a structure so that we are not repeating the same data over and over again in different tables, for example, or even in the same table. So we would just have always one type of data stored in one place. That is why we often approach kind of this relational database modeling from kind of thinking about what are the things that we are looking at and how do they relate together. So that is kind of the mindset we have on that side of things.
Yeah,
And so,
absolutely.
of course,
Yeah.
if we normalize that database, then there's less data to store and so forth. But of course, if we look at the modern day, that is not kind of our main goal anymore, to have as little data as possible. And we can have that data in a different kind of structure. And that is why these NoSQL databases have been approaching, also due to the fact that, of course, there are in these relational databases, you have these constraints. And when you have data models that keep changing fast and frequently, as you were already telling us, it kind of isn't flexible enough anymore for that purpose. And that is why these NoSQL databases have come to be. And we are more focusing on being able to have lower latencies and higher availability rather than the normalization side.
I think you've just explained that so fantastically well. I personally have no other questions.
All right.
But I think that this very short, brief history lesson actually makes a ton of sense, because I do remember, like even in the uni, they would have us calculate bytes and stuff like that and work literally with bytes, right? And every character, one ASCII character, requires 2 bytes, right? So for storing all of this information, where you'd have a string of say 16 characters or whatever else, right? You count it by ×2, and if that is your product category information, for instance, not maintaining the category but rather a reference as an integer, which is just 1 byte, which is a reference to the product category, means that you're saving a lot of space. And the idea 50 years ago was that space in terms of storage was very, very, very expensive. So the way you would save, well, money was to figure out ways in which you just have references to your data rather than repeating the data. It's so well put, but it's so
Yeah.
ridiculous that 50 years later we still think of that in terms of
Yeah.
data storage, right?
But still, that kind of mentality is very efficient for reporting.
It is. It definitely
So
is.
it still works for certain scenarios.
So can you use NoSQL for relational workloads like reporting, as you have mentioned?
Well, it's not. It is not necessarily designed for that from the get-go. But it is interesting to see how things are developing because we are getting capabilities into, for example, Cosmos-db that make it possible for you to use it as an analytical store. And I believe there will be more on that on later um, modules as well. And we can jump into a deep end here if we start talking about this, but there are more of these capabilities that also make it suitable for those use cases as well. But it's kind of, we need something in addition to make it perform well for those scenarios.
But let's not spill any spoilers to the upcoming sessions.
Yeah,
Not that
exactly.
one could not just look at the learning path and figure out what exactly we're going to talk about, but that's a different conversation, right?
Mhm.
But yeah, absolutely. I mean, I couldn't agree more. If you want to use NoSQL for your typical relational workloads, go ahead, knock yourself out. You can do it. But in all fairness, I think you spotted one thing very well. Initially, NoSQL, the modern NoSQL, because NoSQL existed just like SQL for over 50 years. It's
Yeah.
not a net new approach to persisting data, by all means. NoSQL can even be your file system at the end of the day, right?
Mhm.
It is unstructured, it is unrelational, and therefore it is NoSQL. But taking a couple of steps back, this modern approach towards persisting entities, tuples, documents, whatever have you, in a technology of sorts, whatever you want to call it, may it be Cosmos-DB, for instance, with either of the APIs, initially back in the day was mostly focusing on key value pairs.
Mm.
So, for instance, running a query on a bunch of a large data set with a bunch of documents that would not confine to a single schema would make it difficult for the engine to determine those documents which would have a given property with a given value, because there is no concept, or there was no concept of an index. And this is where, to highlight or to enhance what you were saying previously, Heini, this is where Cosmos DB kind of makes a bit of a revolution to an extent, because you do have indexes, you do have
Mhm.
stored procedures, you do have the ability to run queries and properties, even though not all your documents confined to a schema, right? You get all of those capabilities, which are typical to your relational world. You even have joins, for crying out loud. I mean,
Yeah,
seriously.
exactly.
And it's still non-relational.
Yeah.
NoSQL databases are often used when a relational database cannot meet the desired performance or the scale or the availability needs of the application. And that's the reason for why I'm emphasizing that if necessary, you can use NoSQL for relational workloads. The techniques for designing a NoSQL database obviously is going to be different from the techniques where you're modeling data for a relational database. And these techniques are also not intuitive for someone who has a strong background in relational databases design. So some of the
Yeah.
best practices that you might have learned from building relational databases will not translate well to your non-relational database design. And when I say not translate well, I might not do enough justice here. It literally means that you might design a database which is underperforming in terms
Yeah.
of Cosmos DB, just consumes too much RUs, or has more latency than necessary, or just, well, has very slow queries, and so on and so forth. The good news is that if you work a bit on your data model, which is no trivial ask, then you actually can literally leverage the performance that Cosmos DB has to offer, and NoSQL in general.
Exactly.
And
And
to
I think
begin,
the important thing here
yeah,
is to remember not to take the relational database as is and dump it into Cosmos DB, but realize that we actually do need to have some different kind of model in place.
I
And
couldn't agree more.
actually, we have a very relevant question here from Kenneth on YouTube, and he asks, do you see a merge coming in the future for the relational and non-relational database engines? So that there would be just single database engine or instance that supports both relational and non-relational DBs.
This is, I do appreciate that, Kenneth, actually, and thank you for this question. I was a little surprised, he said, with the announcement of SQL Server 2022. Maybe we should emphasize that NoSQL, at least not at this point, is not here to replace SQL, whatever technology you want to call it, whether that's SQL Server or anything else. In all fairness, though, if you're actually looking at the announcements or the new capabilities that SQL Server, just to give you an example, just to put name on it, has on the latest version of the product, you will learn that most of these new capabilities are in terms of connectivity to Azure and hybrid and expanding data sets, some encryption and security capabilities. There's nothing net new in terms of accessing data, persisting your data in memory versus the disk or whatnot. The technology, generally speaking, overall, conceptually at least, has remained the same for several decades, right? There's not much to do, but it still excels when it comes to OLAP cubes, when it comes to data mining, when it comes to transactional workloads, which are beneficial for the relational workload, running your reports, for instance, running business intelligence, right? The same mindset, for instance, over the years has been implemented into creating something that is or was known as the Perl Data Warehouse product. Later on, the Perl Data Warehouse actually was turned into an Azure offering because, in all fairness, the on-premises product didn't get a lot of attention, maybe marketing, maybe we don't know, maybe it just required too much underlying resources. We don't know. But over the years, that product, the Perl Data Warehouse, actually turned into what people knew as SQL Server Data Warehouse as an Azure offering, or Azure SQL Data Warehouse, sorry about that, which nowadays we know as Azure Synapse. Part of Azure Synapse, of course, not all of the Azure Synapse, with the SQL pools on Data Warehouse and so on. So the SQL world, especially under the SQL umbrella, is here to stay for the years to come. And I would put we say in Romanian, I would put my hand in fire for that, right? I would put my money on it, so to say. Is NoSQL going to replace? Again, I can only speculate. But I fully agree with Haney and what she said previously. We are most likely going to see more enhancements, more features, more capabilities added to NoSQL to literally leverage the overly impressive expanding capacity of storage and parallelization that the cloud offering has to offer, Cosmos-DB, whilst we're also going to see the relational workload getting some touches, some improvements, some more polishing in terms of security. Because, I mean, let's face it, the world right now still runs on relational databases. When you go to your bank, when you go to your local council, when you go to anywhere else, right? They're going to be heavily rooted in relational. They're not going to snap their fingers and rewrite everything from scratch. I don't know if that doesn't answer the question, what does?
Yeah. All right. Then we're going to go into figuring out what are the access patterns for your app and why do we need to do this, Alex?
This is one of the very entry conversations related to NoSQL, because when you're designing a data model for a NoSQL database, the objective is to ensure that operations on data are going to be done in the fewest requests possible. And what's particular about Cosmos-DB and many other technologies as such is that when we say request, we're not referring to a special protocol of data access, as would be the case with the Tabular Data Stream Protocol, TDS, on SQL Server. It's literally a request, an HTTP request, right? So you want that request to be super quick and have a response back and be done with it. So to do this, you need to understand the relationships between the data and how the data will be accessed by the application. Let me put it the other way around. When you read the slide decks or the Microsoft Docs article on Cosmos-DB, you will repeatedly read one thing, that Cosmos-db offers or guarantees a single-digit millisecond latency. I'm going to repeat that. Single-digit millisecond latency. That's like blazingly fast, right? Obviously, the caveat is that you're within your region. So don't imagine that you're calling from Nepal over in West Europe and you're going to get single-digit millisecond latency, because the electrons have to move a bit longer. But as long as you're within the region, it's going to be super blazingly fast. Now, how do we keep that single-digit millisecond latency working if you were applying NoSQL? Well, worst case scenario, if you're in the position of rendering, say, your e-commerce webpage and you want to look at your user profile, if you need to run 10, 20 different requests just to render this webpage, I couldn't care less about your single-digit millisecond latency, because now you have to times that by 20.
Yes.
Right? So exactly. Thinking about your data model so that you only do one request means that everything will be snappy fast, right? But if you have to do many different requests, that multiplier is just going to kill the performance. And that's why data access patterns are so important.
Exactly. And when we're talking about this e-commerce sample that we had in our first picture, there are a few things that we might be wanting to do. For example, if we're looking at the customer, we might want to create a customer. So when they enter the service, we of course need to create some kind of information about that user. Then when that existing user updates their profile, we might want to update a customer. And then on the other hand, we might want to, for example, retrieve a customer based on when they visit the site. We need to get some of their information. Mm-hmm. And when we're doing any of these operations, we're going to need all that data at the same time for the entire kind of customer entity. And we could, of course, have these different things that relate to the customer. For example, the customer address, customer password, etc. We can have them as separate documents, as we had in the table example. Or we might need to think that, well, do we actually need all that information at once? And if we do need that at once, then it might make sense to bring all that information to a single document, because again, as Alex was saying, are we making many requests, or are we just calling one request to get all the data? So if we look at this example here, since it is stored in JSON format in Cosmos-db, we can have these one-to-many relationships between the customer and customer address as an array within that JSON document here.
Now, we did look at the diagram previously, and over here what we're seeing is this idea that would be very specific to relational, right? Where you have your customer table, and then you have your customer address table and your customer password table. But rather than referencing them, as would be the case with your relational world, as you see on the left side of the screen right now, in NoSQL, ideally, you put them in, you embed them together as a single object of sorts, right? If possible. Sometimes you can't do this, and we're going to talk about that as well. So how do we achieve that? Or better put, when to embed or not to embed, or when to embed reference data, which is our next topic. How would you answer this question, Haney? Like, when do you embed, when do you not embed?
Well, we have to think about that access pattern as we were talking about. So if you have information that you are, for example, fetching all together or updating together, then it makes sense to have that embedded, because you are getting it in one go and you don't have to go into multiple places to fetch multiple documents and then kind of put it all together and figure out how to work with it. Then also, if you have a one-to-one relationship between different entities, so for example, the customer and customer password that I mentioned before, each customer only has one password. So that makes sense to embed as well, because we are not, again, it is just one-to-one relationship. So why would we then separate that into different places? And in a NoSQL database, we could also have a one-to-many relationship, or in this case, a one-to-few relationship. So for example, the customer and customer address, So for example, in these applications, you might just have a certain amount of addresses that you can have in place, for example, the billing address and shipping address or something like that. And we know it is kind of bounded. It's not going to grow infinitely. Then it might make sense to embed that information in your document as well.
Yeah, I think this is spot on. But there are some scenarios in which I think it's better to reference data. Reference data is what you normally do with this idea of denormalization that you have in your relational workloads, where you have like separate data sets or separate documents, as we refer to them in the NoSQL world. For instance, if there is an independence between reading or updating the data, right? Especially
Mhm.
true for such a scenario when you reference data, when you're combining entities that would otherwise result in very large documents out of which you don't actually need everything. Because remember, Heini said previously, if you're pulling data together, embed them. But if you're pulling data and you only need like 30% of the data, and you also need to update the other 70% maybe more often than the other 30%,
Mm.
this is already an indication that it's probably better to keep those data separate and just reference them somehow. Updates in Cosmos DB require the entire item to be replaced. Actually, there's a caveat to this one because there is an update to the SDK, which nowadays gives you the ability to patch the item. But keep in mind that you need to use the latest version of the SDK with the latest version of the NuGet packages installed, with the latest whatever, with the latest whatever, with the latest whatever, right? So this is a new capability that was introduced, what was it, like 4, maybe 6 months ago?
Yeah, something
Um,
like that.
yeah. Another another scenario is, and this is especially true for referencing data, is when you have like a relationship which is unbounded, like a one-to-many relationship which is fully unbounded. So azure-cosmos-db actually has a maximum document size of 2 megabytes. This might change in the future, we don't know, but if your document would end up being a larger document than 2 megs, then for sure you need to separate the data. Or I actually was in a scenario once where the size of the document would dynamically increase depending on the utilization of that particular document. So
Uh-huh.
this was kind of a no-brainer. Hey, wait, we can't keep
Yeah.
pushing the same data to the single document. We got to separate this because otherwise we will have some documents like super small, super tiny, and others just keep on growing and growing and growing towards 2 megs. And maybe at some point they would even go past that one value. So this is also something super important. And then we have the many-to-many relationship, and we're going to explore this one in a later unit with the product tags, because remember, product tags are working with a many-to-many relationship right now in our design with this e-commerce application. But having this insight into when do you embed versus when do you reference data is going to be very important, both for the purpose of the exam and also for the purpose of properly implementing Cosmos DB in your own apps. You know what Linus Torvalds said once?
Not sure which particular quote you're referencing to.
Because there are quite many, right?
There are.
Enough talking. Show me the code.
Oh, that one.
I think it's a good time to maybe get our hands dirty with some code.
Yes,
Want to show us
I
something?
think so too. So, as usual, you can find the exercise in the Learn module that we have been working through. I'm going to show it a little different. So, when you're walking through the Learn module, you can find a place to have a test environment in Azure. And then you have everything prepared for yourself. You don't have to install anything on your own laptop or anything like that. I just sometimes like to use my laptop, preferably, and it allows me to do some preparation ahead of time and, make things ready for this particular use case. So I have done some preparation, and I'll just walk you through it, what we have done and what you will need to do, kind of get started with this particular exercise. So in this exercise, you are asked to use the Azure Cloud Shell. And I, in this case, actually used my local bash, but you can find the Azure Cloud Shell in the portal. And let me just turn my head a bit here. So you can find it always here when you go into the Azure portal, you can open it here and you just create a storage account for yourself. You have instructions in how to do this in the exercise, and it'll walk you through it, how to create it. And after that, you can run your commands here, and even you can clone this Git repo where these exercise scripts and things are stored and clone it to the Cloud Shell.
I always say that this is my favorite this is my favorite that. Cloud Shell, really, I kid you not, Cloud Shell is one of my favorite features, and I must explain this why. It's only going to take
Please
1 minute.
do.
So Cloud Shell on one end is actually running inside a container. It is running based on a container image that Microsoft put together, which has a ton of CLIs, like the kubectl, the kubecontrol, or what kubectl, whatever you want to call it, right? GIF or GIFs, is installed. The Docker CLI is there. The Ansible CLI is there. The Terraform CLI is there. The Azure CLI, of course, is there. There's so many CLIs pre-installed that you don't need to install them on your machine. Number two, you can get Cloud Shell inside Windows Terminal, and you can effectively have all of those CLIs running in the cloud and work with them directly from your computer and access your data from your own local disk on your machine. How crazy is that? In Cloud Shell, there's something called Cloud Shell Editor, which is actually a super lightweight version of a Visual Studio Code editor. So if you clone, like you've mentioned previously, and then you need to edit maybe a JSON file or whatnot, you can do that directly in the browser and not even think about VI or getting VI trapped, which, in case you're not familiar with VI, is just a horrible text editor. And now I know half of the audience is just hating me for saying that. But still, there is Visual Studio Code directly in Cloud Shell, and there's so much more to it. I think it's great. You know what my favorite feature of Cloud Shell really is?
What?
I can take my phone, run the Azure mobile app, and I have Cloud Shell on my mobile app or even my iPad right here, and I can work inside Visual Studio Code, well, whatever version I have there, and literally do anything from the CLI, the Azure CLI, from my tablet, wherever I am at. How crazy
that is pretty cool.
So
definitely test it out. I have now been inspired as well, definitely. But this time I have just my Visual Studio Code. Sorry, everyone. So the first step that you are going to do is that in this exercise file, you have this init sh file, so a bash script. And I actually edited this a tiny bit because there was this caveat that you can only use this for provisioning resources in an Azure subscription that has one resource group. So you need an Azure subscription that has one resource group, or on the other hand, the default setting of this would have taken the first resource group that it gets. So that would have been the default way. So I just typed in my resource group that I had available where I wanted to create my resources. So that's that one. And actually what this is going to do after that is that it is going to create a resource deployment to this resource group. And what it is going to use is this Azure deploy JSON. So if we check this file out, this is actually something called an ARM template. And this is what defines what kind of resources you want to create in Azure and what their names are, any kind of configuration that you want to put in place. If we just briefly look at this, for example, in the beginning, we have some parameters that we can set, the account name and location, for example, the auto scale max throughput. There could also be some variables, which we don't have in this case. And then we have the actual resource definition area here. So for example, we are creating a Cosmos-db, which we can see that the resource type is actually Microsoft.document.db. And then we're specifically creating a database account. So if you walk through this template, you can actually learn quite a bit about the configurations that you can do for your Cosmos-db account and kind of take a look behind the scenes of what are all the things that you can set, which you might not always see all of the things by default in the portal while you're creating a resource. You might see them then in the settings after the fact. and so forth. So this is kind of the programmatical way to define your resources. And since we are running this script is grabbing that Azure deploy.json file and passing it to the Azure ARM API that then will know what to do with that configuration and knows to deploy the correct resources. So a nice programmatic way to create resources. I'll do a lot of things similar to this, though I do not use ARM templates. Let's not get into that topic, but there are some easier syntaxes to use as well. And
yeah.
yes, exactly.
Now the other half of the audience is going to hate you, Heini, for saying
Yeah, I know. But there is Bicep. I personally use Terraform, but yeah, there's many options to use. And then this is just going to grab the URI and the key of the Cosmos-db account that we create. And it's just going to print some settings there. And actually then going to write into this app settings.json file over here, those informations that it just printed. And what we needed to do after that is we have these .cs files here as well. And to get this all working, we actually had to add the Microsoft.azure.cosmos package and run that and add that in there. And then we needed to build it and then run this. And what this program actually does is it adds data into our Cosmos DB. So this is just to prep so that we have a Cosmos DB that has some databases in it and then some data in those databases as well, so that we are then able to compare the performance. Otherwise, we wouldn't be able to do it. And like adding this much data manually would be kind of a lot of work. And I actually put this to run a little before we started, and it took maybe 10-15 minutes to run and get all that data in there. So I just thought we might not want to wait that long. So I prepared that, but just when you're doing the exercise, be mindful of that. And there are the commands that you need to run to get that data in there described clearly. But that
so effectively,
means
this is application end-to-end. In case you do not have a playground, is deploying the same playground, right? That's the purpose of the ARM template. Idempotency,
Exactly.
another fancy word. Every time you run it, the output is the same. The outcome is the same. And second, the C# application is just filling that account, that whatever containers you have in Cosmos DB with exact the same data. So everyone has the same data. If they would follow the same steps that you are going to follow from this point on, that you're going to do from this point onward, running the same queries would render the same results at their own end, right?
Exactly. Yeah.
Nice.
Right. Good clarification. So I have my resource group here, and I can also find this Cosmos DB that has been created for us over here. So if we go looking into the Data Explorer, we can kind of check what has been actually created in this Cosmos DB. It is coming. I was looking at it for a moment, like, that looks a bit blank. And we can see that we actually have 4 different databases in here. And as we're walking through this, I'm just going to run a few samples. I'm not going to run all of the queries that are in the exercise, but just a few to give you the idea, and then you can run the rest on your own. But we can take a bit of a look of what's in here. So we can find in this database 1, we can find that there's the customer address, the customer password. All of these are different containers here. So all of those are kind of separated into their own entities here. But if we compare it to, for example, the database V2, we can see that some of these have been grouped together. So for example, in the customer container, if we check at one of these items, we can see that this also contains the addresses. So in this case, we don't have a separate customer address container, but it is actually embedded here. So these different databases that we have here are kind of representing those different scenarios of, are we embedding certain information in the same document, or do we actually have them in separate documents? And then, of course, what we could also be checking here for each of these containers is we are, of course, able to see the settings. So we're able to find out, for example, what are the max RUs that are in place. What is the partition key? That is something that we might be interested in checking as well. We're able to dig in and see how those different tables, the containers have been created here. So we're just gonna run a few commands here against these different databases. So if we, for example, take the database 1 and we select the customer, let me just close that real quick. And there is the new SQL query. We are able to run a query. Let me just do that. That might make it easier to see. So we just have a query where we're fetching for a specific ID. So we can just run that. And we can see that we were able to get one item. All right. I am wondering if I'm the right place. Let me just double check. I think I managed to be in the wrong place, actually in the different table. Let's just double check. I have to say, like, the portal user interface isn't always the easiest for especially sharing because the windows want to go so small. But
yeah, the screen estate isn't the greatest one, but usually the experience isn't the one that we're currently seeing on the stream, right?
Exactly.
You're zoomed in at what level right now? 175%?
Something like that. So it'll be nicer for you doing this on your own laptop. I just have to have it quite big here to have it visible. So of course, what we might want to do here is look at the query statistics. And yeah, it doesn't want to expand that. But what we can, for example, find here is that we can find the request charge. And we can see that, well, it's one result that we're seeing 1 out of 1. And we can see how big the document is that we fetched, etc.
And right now, your result contains which properties? It's just some customer data, right?
Yeah, just some customer data. So
like
there's
name,
the title, first name, last name, email, phone number, and so forth. But for example, no address.
If we are to consider this fictional scenario with the e-commerce application, if you go to your user profile, you're definitely going to see your first name, your last name, your phone number, your email address, which is already here. But arguably, you want to see additionally, I guess, your physical address, like a shipping address, maybe validate the password. So how do you do that?
Well, then it means that we actually have to go to the customer address table. And in there, we also want to run a query. And we just need to have the same customer ID, of course, there in place. And then we need to query this customer address table as well. And we find this item with the customer ID and then the address information.
So all of this information is segregated into different collections, into different containers, and you just have to run a request, for every one of these. What is the query stats for this one?
So if we look at this one, we again have the 2.83 RUs that are used for this one. And then if we wanted the password as well, we would have to go now to the customer password table as well and run the same query, essentially, again, to get that password for that single customer. And we would see the same RUs there again as well.
I trust that people already foresee what the problem is here, and we can speculate. Like for rendering a single page, we ran 3 requests, super basic example, and we have a charge not of 283, but rather the accumulated sum of all of these, which is probably going to run somewhere around 9 RUs, 8.49, I guess, or something along those lines, depending on what the actual RU for each of these queries really is. If you're not familiar with the term of RU per second, because this is RUS, right? This is the actual amount of throughput capacity that we're utilizing out of the max available on your container or your database. So one user going to one web page is going to chunk out from rendering that web page almost 9 RUs. How can we minimize
Exactly.
that time?
So we might want to compare it now to our database version 2, because here we have just the customer items. And we might want to go in here and actually run a query against this and compare what happens. What do you think will happen, Alex?
I would speculate that your overall request unit charge is going to be 2.83, and you're going to have all the data necessary. So we went down from 8.49 to 2.83, run a single request, not have additional latency involved, and have all the data in a single shot.
Yeah, exactly. So that is, we get all the results in one go. So we get the name and all that information related to the customer, but we also have the addresses there. Plus, we have the password as well. Well, the hash of the password in this case. So
nice.
Just one query. We don't have to go into 3 different places to fetch the data. Instead, we just fetch it from one place. And for this scenario, it makes sense to embed, because we, of course, want to have that information at the same time. We don't kind of want to update it in separate goes. Didn't find the word there.
Yeah.
So even with it just querying this for one user, the difference is quite huge. We get to 1/3 of the request units by having these embedded in one place. So that is pretty significant, especially then when you think that there is a lot of users on your web page. So that is the sample for this particular exercise. You have all these tables available. So I do recommend you to kind of look through the other databases as well and kind of test around. I couldn't see any difference to that. But here to the database version 4, there is, for example, the product meta groups together some of the product tag information and so forth. So you can kind of go around and poke and really test around that. What kind of queries, where can you see the difference? And again, think about the access patterns of the application itself. Because if you have the intention to separately update some information, then it might make sense to keep it separate, because you actually want to go to these different collections separately. But if you are updating it at one go, then we need to look at these embedded options. But you have a lot of data to play around with here. So go a little beyond the exercise instructions and play around, create your own queries. It's also a great opportunity to just get familiar with the query syntax as well and understand how to write those queries.
And there is definitely a ton of other scenarios in which embedding data makes a lot of sense, but sometimes you're still going to embed data because most likely the data is going to be more frequently read rather than written. And yet, when you're writing the data, you don't want to have a single query running for a crazy store procedure that's going to update a bunch of different containers, which is even virtually impossible, right? So the way you achieve that is, well, number one, you go to the recordings on YouTube of this Microsoft Learn Live TV and you watch our lesson on implementing change feed, and you're going to learn more about change feed and how you implement change feed for referential integrity, or just read on Microsoft Learn Docs for that. Heini, your demo actually triggered somebody in our audience. Tommy on Learn TV asks, can you do this Cosmos-DB ARM template thingy that you've shown so that it is added to an Azure DevOps pipeline with continuous integration and continuous deployment?
Yes, definitely.
Absolutely. Absolutely.
It would be good to, like, if you're actually, this would be setting up your real environment and you want to have those infra level changes under your control as well. Yes, you would want to have those in your CI/CD pipeline. When we were looking at this particular sample, we had this shell script that was actually deploying the ARM template. So that is done a little differently in the Azure DevOps side. So for example, you might need to fill in the resource group name as a variable and so forth to get it to function correctly. Plus, then this also added some information in this app settings JSON file here. So you would then need to have that logic in your pipeline as well. But yes, definitely.
And just to also add to this, you don't have to run a shell task like Heini did previously. There are specialized tasks for deploying a resource group template or an ARM template at the subscription context or the management group context.
Exactly.
And you virtually just fill in a bunch of properties in the classical workflows for builds and releases, or alternatively use the YAML-based definitions in your Azure DevOps pipelines, either whether you're doing CI or CD, that's up to you really. But there are tasks specifically designed for the purpose of deploying an ARM template.
Yeah, exactly. Good clarification.
Yeah, it's just about getting stuff easier done, right? Because otherwise,
Yeah.
with the shell, you'd have to somehow authenticate your AZ contacts, maybe run an AZ login prior to that. We can just simplify that by using one of these specialized tasks instead. Very good question, Tommy, and thank you for that.
Yeah.
Cool. That was a very good demo. Really appreciate it. Very nicely put.
Yeah. Thanks.
Now, we are slowly but surely heading towards the end of this presentation today and this episode, but there's still a couple more topics that we want to touch on. And one of them is related to partition keys. Because yes, the way you think about your data structures and your data models is going to be important, but picking the way you structure the data physically is something that it's not your responsibility, but you can indicate somehow to an extent to Cosmos-DB how the data should be structured. And this is where picking a partition key becomes such a very important task. Because you need to remember that data in JSON documents in Cosmos-DB is always going to be stored within the containers. Of course, is always going to be stored in a distributed manner, distributed across physical partitions, where the data is routed to the appropriate physical partition based on the value of the partition key. So this partition key is obviously going to be a required document property, because it is going to ensure that all the documents within the same partition key value are going to be routed to and stored within the same physical partition. Why is this important? Because whenever you're running a query against the partition, it's going to consume part of that partition's resources like CPU and IO and whatnot for retrieving the data. So not having a properly chosen partition key means that you're fanning out the request. What does fanning out the request mean, Heini?
Well, that means that we are having to, when we are running one request, we actually have to go to multiple partition to fetch the data that we need, instead of actually just going to one single partition and getting all that data just from that one place.
Absolutely. So if you were to put it differently, think of the scenario where you're saying, I want to pull the information on Heini, right? And our partition is not the first name. So what this means is that if we have multiple physical partitions, then you would just pull the data from here, or maybe from here, or maybe from here, or maybe from here, or from here, or from here, from all of these partitions, because you cannot indicate where the data actually resides at. So this becomes super, super, super important. So the key really for partition keys is that the partition key ensures documents within the same partition key value are going to be considered to belong to the same logical partition, and they're going to be routed to or even stored within a specific physical partition. So the concept of a logical partition is therefore to allow the grouping together, of course, of documents with the same partition key value. And multiple logical partitions can be stored within a single partition, and the container can have virtually an unlimited number of logical partitions. Individual logical partitions are going to be moved to new physical partitions as unit as the container grows. So in moving the logical partitions as a unit ensures that all the documents within it would always reside inside the same physical partition. Now, there is a max size for a logical partition, which is 20 gigs. You might argue this is a large size, but keep in mind, we have always said that Cosmos-DB, at least in theory, it's a marketing pitch, has unlimited capability of expanding your storage, right? Nonetheless, there is a limit on the logical partition, which is the 20 gigs, at least as of right now. So using a partition key with high cardinality to allow you to avoid this 20 gig limit by spreading your data across a large number of partitions is going to be important. But now we've introduced another interesting word, cardinality, high cardinality. What does that mean, Heini?
The cardinality means that you want your data to be spread out over different partitions, and so that also it is spread out evenly.
Yeah. The way I think or explain to my 5-year-old what cardinality is, because I have conversations on high cardinality with my 5-year-old. Of course. Is think of your data structure as a table, and then think of how many duplicates you have on one given property. If you think of something that can be a Boolean value, false or true, or maybe the list of countries, right? That's kind of limited. They don't expand too often, at least.
Yeah.
That is low cardinality, because you might have billions of records out of the 140 countries that your business operates in, for instance, right? That's low cardinality. If you think of an identifier, because they're unique, that's high cardinality, right? So we just said that if you're using a partition key with high cardinality, so something that is usually doesn't have duplicates, it would allow you to avoid the 20 gig limit. But this is a completely new ball play now, because usually when you think of partitions, especially if you're rooted in the relational database models, is that you would think of each partition as a customer. And one customer might have more data, one customer might have less data. What are you talking about of splitting my data by the identifier because that has high cardinality? That's you must be wrong, Alex, right? Well, no. Because the thing about Cosmos-DB and all of these NoSQL technologies is the even distribution of your data. Remember, the CPU, the I/O, the memory that you're getting is on the physical partition. So if you end up having one physical partition pertaining data for one customer, and that customer is right now really in need of a lot of throughput, but you're splitting your overall throughput, say 30,000 RUs by 6 customers, you're going to get 5,000 RUs per the supposedly 6 physical partitions that you have. So if one customer at some point reaches the 5,000 RUs that you've had, you're going to have customers which are just not spending RUs available to the Cosmos-DB account, and one customer having a very hard time running their queries because they're running out of the RUs. And the sad part about it, you're still paying for 30,000, but you have customers which are throttled. So you want to think of high cardinality so that everyone gets the best advantage of all of these RUs available. But the downside of that has to be, where do you pull your data from so that you don't end up fanning out, running across partition, just like Heini mentioned previously. So there's a bit of a trick to this one, right? You want to definitely avoid hot partitions. When you're modeling your data in Cosmos-DB, it's going to be critical, virtually super important, that the partition key that you choose results in even distribution of data and the requests across physical partitions in the container. This is especially true when the containers grow larger or have an increasing number of physical partitions under them. And if you don't test this properly, you might shoot yourself in the foot, really, because even when you run your test, make sure that you run under heavy load. Because during development, you're going to run a query on a very small data set. You're not going to have more than a single physical partition, so you're not going to really feel a difference. But when the data is not partitioned correctly, you're going to end up having these hot partitions when your application workload, will be prevented from scaling. And this can happen both on the throughput and the storage, as I've said previously. Now, you are going to come across some of these samples as you go through the Microsoft Learn series on storage hot partitions, for example, which occurs when a partition key results in highly asymmetric storage patterns. Just as I've explained previously, you have a lot of data in a single partition right here, and then the other partitions are just almost unutilized. You want to prevent that. Throughput, like I've said previously, imagine you have 30,000 RUs and you're splitting them in 6 different containers or sorry, 6 different physical partitions, and one of them is just getting everything. This one's going to be hot over here, and that customer is going to struggle actually utilizing your application, and you're still paying for all the $30,000 use when customer E and F and C and B and A, they're literally not using the application. So that's bad design again. And you can fix this. How do we fix it, Heini?
Sorry, I missed your last sentence.
Sorry.
How do we fix
no
what?
worries. Yeah. How do we go about not having these hot partitions? Because you know, Heini,
yes.
the important part is choosing the partition key, right?
Exactly.
And considering whether the data is going to be read heavy or write heavy, right?
Exactly.
That's the big deal. That's the end of the day. Just understanding your workload.
Exactly. And kind of whether it is read heavy or write heavy, we do need to consider a little bit different things. So when you have read heavy workloads, as we were kind of looking at with the exercise as well, then you want to ensure that the queries are processed either by one or limited number of those partitions. So that is what you want to look at. What about when we have those write heavy requests? Then we
when you have your go ahead.
Then we more want to, of course, ensure that those writes are done with high cardinality so that they spread out evenly. So it is kind of course, a little different whether we're writing or whether we're reading.
Now, on the premise that we have explained thoroughly partitioning in Cosmos DB, I guess it's also important to decide on the partition key for, let's say, the customer data, as you have seen it in the previous example. In your exercise previously, we saw that you ended up actually merging and embedding all of the data, the password, the addresses, and so on and so forth. What would be a good fit for a partition key in that scenario, Heini?
Well, when we're retrieving the data, it really makes sense to have it by the ID, because then we're able to fetch that customer by the ID that they have.
Yeah, so the customer identifier would be your partition key, right?
Yeah.
And again, if you're coming from the relational model, this almost feels like wrong, because
it does.
It suggests that for each customer you can have partition. But that's the thing. The logical partition do not pertain to the physical partition. It might be an indication on how to physically separate your partitions, but you might as well have one logical partition per customer. It's just going to indicate that you're going to evenly distribute the actual workload to the physical partitions and never have to worry about throughput being limited and your application not being able to scale. Now, again, if you worry that making the ID the partition means that you're going to have many logical partitions, don't worry. That's the big selling point. That's the key takeaway here. Don't worry. There are some interesting concepts around referencing data with this one-to-many relationship. For instance, this data model here includes two small reference data entities, the product category and the product tag. You didn't get a chance yet to expand on the example previously that you were presenting, Heini, but we're going to actually cover this one in the next module. But long story short, when you think about these small lookup entities, sometimes it is not necessary to actually embed them together. Firstly, for categories, for instance, we can model, if we want, data with its identifier and the name columns as the only properties that we put in a container called product category. But next, we would need to choose a partition key for that. So what you normally want to do is explore the operations that you typically perform on this data. Again, understanding your workload, right? Key takeaway, understand your workload. So if you create a new product category or edit the product category and then list all the product categories, these are the 3 types of operation that you commonly do. Creating and editing the product categories are probably not going to be very frequent operations. You only have so many categories to begin with. But the e-commerce application will most likely often list all the product categories when the customer visits the websites, maybe for the purpose of having filters, facets on the left-hand side of the screen or whatnot. So the query that will most likely run the most is select everything from the container. And with the identifier as the selected partition key, this query now becomes a cross-partition query, even though we want to try to optimize these read-heavy operations to use a single partition if possible. So How do we fix that? Well, this is something that a lot of people don't expect, but we can actually simulate a partition and the usage of a single physical partition by injecting another new entity, another new property, for instance, type. And by injecting this type as a partition key and using type as our partition key instead, when we run select star from the container where the C type property equals category, we instruct everything to be pulled from a single category, because you can imagine it's unlikely to have a list of categories that exceeds 20 gigs, right? So we can kind of enforce everything to be in a single physical partition, therefore. And I would do the same with tags, really. Product tag, just enforce the type to be tag. And this is an indication that we want everything to be in a single partition. Some people find this technique actually for modeling small lookup tables to be strange. And I understand why. I mean, I'm obviously coming from the same place. I've used relational models quite a lot. Having these properties to indicate how the engine should store the data doesn't feel like a natural hit. It is a bit out of question. But nevertheless, it is something that really helps quite a lot. Cool. I know we only have so much time left. I know people are super excited about this introductory topic. This is actually going to be followed up in the next episode, and we're going to build on top of what you have just learned. But there are some knowledge check questions, and I believe that it would be interesting to maybe breeze through them real quick. Yeah. I'm going to take the first one, if you don't mind. Which of the following criteria would define a good candidate to embed two entities in a single document schema? A, many-to-many relationship. B, read or update together. Or C, read or update it independently. What say you?
I think it was this one where we want to read or update together, what we were also doing in the exercise as well.
Spot on. Oh, this is a very long one. I'm going to let you actually read this one.
All right, all the reading. So consider the following scenario. Your company has customers across 4 countries with hundreds of thousands of customers for countries 1 and 2, and a few thousand customers for countries 3 and 4. Requests for each country total approximately 50,000 RUs every hour of the day. Your application team proposes to use country ID as the partition key for this container. Which of the following statements is true? Will it prevent throughput hot partitions? Or will it cause fanouts when filtering by country ID? Or this partition key could cause storage hot partitions? What do you think, Alex?
I think it's going to be the third one. The partition key will cause hot partitions to happen. And again, the explanation here is that you're going to have one partition just be more utilized, or a couple of partitions be more utilized by hundreds of thousands, right? It just says right here, hundreds of thousands for those countries, whereas the other ones are just running a few thousand RUs. So if your mindset was, yeah, let's separate everything by the country ID, because that's what kind of feels natural to the relational database, please do yourself a favor, grab a cup of coffee, rethink this, because there's a better way. And then the last one, why is understanding the access pattern of your application and how to use this information in your data design important? Obviously, it goes without saying, because you want to understand the access pattern better, because that will help you identify how to access your data and your requests. I know we're kind of blazing so fast because we're almost at time. We are at time, really. So we really need to wrap it up. Thank you, everyone. Make sure to get your hands dirty with this topic on Microsoft Learn. Again, Heini, it was such a pleasure. I mean, time really flew by today.
It did, so fast.
Good topic, and fantastic having you here to run this presentation alongside with you. Make sure to stay tuned for the next episode. We're going to learn more about designing a data partition technology, and we're going to get you all ready to get certified. Stay safe, everyone.
Bye-bye. Thank you.